Hey mathletes, so glad to be back with you. And in this video, we're going to talk about some more vocabulary that has to do with circles. And particularly, we're going to focus on arcs in this segment. Okay. Oh, that was a little bit of a math pun. Okay. So we're going to talk about more circle vocabulary. Let's start by defining what a central angle is, okay? A central angle is nothing more than an angle that has a vertex at the center of a circle. Okay, so we've situated an angle so that the vertex is at the center of a circle. And so this picture here shows angle ABC as a central angle. Okay, this is important because central angles have relationships with the arcs that they intersect. All right, next, a minor arc. It's not an inconsequential arc. It's not an arc less than 18 years old. It is an arc that is less than 180 degrees, and it's formed by the central angle. Okay, so an angle created by a central angle, and it measures less than 180 degrees. So convention for a minor arc is you just name it by the endpoints of the arc. So arc AC is a minor arc. That would be right here. Okay, got it? All right, so can you guess then what a major arc is? It's not military. What it is, it's the remainder of the circle when we take out that minor arc, what remains, okay? And that measure will always be greater than 180 degrees if this is less than 180 degrees. Okay, now when we name major arcs, we're always going to distinguish them from the minor arc by adding another letter in there. Now, you can name a minor arc with more than the endpoints, but you must name a major arc with an additional point. So to distinguish minor arc AC from major arc AC, we throw in that extra letter and we say that major arc is arc ADC, okay? So that's a major arc. And just like with segments, you can flip-flop the order of the letters. So I could call this arc CA, and it's absolutely correct. Okay, so the next things, let's see. I think they're going to appear now. Okay, you ready? Here's the rest. We'll start with the semicircle. And it's just what you think it is. It's an arc that's exactly half the circle. So that arc measures exactly 180 degrees. Now, as you might guess, if you've got an arc that's 180 degrees, I could name it arc BD, but is that the top arc or is that the bottom arc? You need to put that third letter in so you can tell which one you're referring to. Now, they're gonna have the same measurement and they're gonna have the same length, but we may want to refer to either the top one or the bottom one for a specific reason. So you're going to add that third letter in to distinguish which one it is. Congruent circles. Okay, we talked about this a little bit in class, but congruent circles are nothing more than circles that have congruent radii. As long as the radii are the same length, then the circles are going to be congruent. You could stack one on top of the other and it's going to be exactly the same size. Of course, it's the same shape. Okay. Congruent arcs. Congruent arcs are arcs with congruent corresponding chords. So if you were to join the endpoints of the arcs with a chord, and that chord was congruent to another chord, that is going to make the arcs congruent as well, provided the radii in the circles are the same length. Okay, because to be honest, I could draw a chord that is 2 inches long and it's the diameter of one circle, and it's 2 inches long and it's a little tiny chord on a great big circle. It's important that not only are the chords congruent, but the radii themselves are congruent too. All right, and then the last thing will be an inscribed angle, okay? An inscribed angle is an angle formed by two chords and a vertex that lies on the circle. So put two chords in the circle with a common endpoint and you formed an inscribed angle. Looks like this, right? So this is angle GJH, and it is inscribed in that circle. All right, 2 more things in this video, and then we're gonna move on. All right, here's the last little bit. Let's talk about the measure of minor arcs. All right, the measure of minor arcs are closely related to the central angles that form them. In fact, they're the same measurement. So if you're looking at the measure of a minor arc, it's always going to equal the measure of its corresponding central angle. For example, here you have a minor arc DF. This measurement is the same as the measurement of its corresponding central angle. So the measurement of arc DF is the same as the measure of angle DEF, which is going to be 94 degrees. Now, remember that the measure of an arc is not the same as the length of an arc. The measure of an arc is going to be calculated in degrees, but the length of an arc is like the length of a line or the length of a table. It's going to be a linear unit like centimeters or inches or meters or whatever. So keep in mind that those two things are different. An arc's measure is going to be in degrees, while an arc's length is going to be in linear units of some form, okay? Now, the arc addition postulate is really simple. All it says is if you've got 2 arcs that are adjacent to each other and actually share an endpoint, then the measure of the arc that they form together is just the sum of the measures of the individual arcs put together. Okay, so I think I wrote it like this. Ready? The measure of an arc formed by 2 adjacent arcs is the sum of the measures of the individual arcs. What does that look like? We'll take a look right here. The measure of arc PQ plus the measure of arc QR is going to be the measure of arc PR. That makes sense, right? They're right next to each other, so I can just add them together. Okay. In the next video, we're going to talk a little bit about inscribed angles and how they relate to central angles and arcs and that. So stay tuned because it kind of gets interesting. See you then.